Hi everyone, I'm Dr. Mary Burke from the Geography Department in Trinity College Dublin, and thank you for the invitation to come and speak to you today about some of the academic background and research around how we might better manage our river catchments. So today this talk is going to be divided into three parts. We're going to start off with the basics, introducing you to what a catchment is and how the water moves through it. What is a floodplain and how we might use these floodplains better. We'll then move on to talk about some of the issues, like what have we done to our landscape to really disrupt it and make things more difficult for us in living in this landscape. And finally, we're going to talk about the future, a future that I'm very optimistic about in terms of employing nature-based solutions to help kind of attenuate some of these more negative effects that how we manage and live within our catchments are affecting both our water quality and the flood hazard that we experience. Thank you. In Ireland, we take a catchment or a drainage basin approach to managing our rivers. You'll be familiar with the term integrated catchment management. So this slide is to basically show you what a catchment is and to let you know that the term catchment, watershed and drainage basin, they all mean the same thing. So this dotted line here outlines physically the boundary of a catchment, and it's defined basically by which way, when rain hits the ground, it flows. It'll flow downslope towards the main trunk of the stream. So this is the important component in terms of both what it actually represents for water flow, but also the scale of it. This is a large-scale catchment unit. For the effective management of our river catchments, we need to look at the smaller divisions, both topographically and hydrographically, that are contained within that system. So basically where we have small first order tributaries feeding in, that is a sub-catchment unit. And they join together to form larger units. And it is very important when thinking about the nature-based solutions to our river issues and river management that we realise that they are most effective at these smaller scales. Now you combine that with the fact that our rain gauges, our towns, villages and cities are all located down here in the largest component of a river catchment. And the main premise of the nature-based approaches is that many features in multiple locations at smaller scales and low cost will combine to mitigate some of the water quality and water quantity, as in flood issues, that are experienced further down the system. So you would be familiar with the hydrological cycle, where you have water vapor in the form of clouds that condenses and forms precipitation, which flows across and through our landscape, reaching the streams and rivers, lakes and oceans. Evaporation happens again, and there the cycle continues. What is important is the detail of these components, because at every point, whether we have overland flow, whether we have through flow, whether we have soil pipes where we've got rapid movement in the soil of water, whether there's vegetation intercepting the flow, these are all points at which nature-based approaches can be implemented to improve the water quality and to slow down the movement of water over and through this system. Now, as that water moves across and through our landscape, it transports sediment and eventually deposits it. And so that brings us to the bottom of valleys, and we're now going to look at what we find there in terms of landform units. So in Ireland, very commonly, our rivers are alluvial rivers. So we have channels and we have floodplains that are features that are generally quite flat, that border a channel, that are periodically and very naturally inundated during higher flows. And what's important to note here is that it's not a flat surface or it shouldn't be a flat surface. Naturally, it's not flat, that there are lots of different shapes to that floodplain surface. If we look at a schematic of an idealized river flowing through a valley, you will see that where tributaries come in, they can deposit water and sediment on the flat surface that they intersect with. This is often a floodplain. The floodplain, as I've mentioned, can have many morphologies. Some of them we learned in school, known as oxbow lakes. But the floodplain is a natural feature which has been built up over thousands of years by successive floods depositing sand and silt and clay, and sometimes during enormous floods it can deposit boulders. But what's important are there, as well as the different topographies that we find in the floodplains, are also the natural occurrence of swampy or boggy areas. And it is the removal of these from the Irish landscape that has led to some of the water quality and water quantity issues that we now experience in Ireland. So here is an aerial shot of what a typical Irish river may have looked like before humans came in and intervened. And you can see here a naturally meandering stream, and these streams are dynamic. They are meant to move, and they move across valley bottoms laterally. And when they do, they leave behind traces, just little fingerprints of where the channel was before. And these topographic lows are excellent opportunities for us to utilize to temporarily store water so that we can both filtrate some of the more harmful products out of the water, but also reduce the hazard of floods. Now we're going to focus on some of the issues that we have created. We're going to look at what the problem is. We are the problem. We are the problem in terms of what we have done to our landscapes, to our catchments, since we arrived as humans on the island of Ireland, and how the development of agriculture, in particular agricultural practices, have led to some of the more major issues that we experience in Ireland. So if we look here on the top left, what we can see is an idealized system of early agriculture where we had the implementation of field boundaries, the increase in stocking density, but a fairly kind of balanced system with rivers. However, more recently with technological developments and the industrialization of agriculture, we have taken over our rivers and attempted to make them work for us in terms of making the land drier or providing a source of water for our crops. We have employed several types of industrial machinery that changes the soil properties. So this has led to, and this is proven scientifically through various studies around our planet, it has led to an increase in flooding, and this is without climate change. It has led to an increase in pollution, i.e. a decrease in water quality. It has led to more incidents of drought, it has reduced our biodiversity, and it has increased the carbon loss from our natural systems. So let me give you an example of what humans have done. So here we're looking at our drainage basin or our catchment, and this is a river system with what we would call a low drainage density. There's not a lot of surface channels on this. And if we were to put in a discharge gauge, and we look here, Q is discharge and T is time. With events, we can see that we do have a raising of the level of water in a river, but it tends to be a low peak and a broad temporal framework. Now, when humans came in, they needed to adjust the landscape so that they could provide food for their families, etc., and communities and society to grow. But with the more modern interventions, what we have under government legislation and funding was the implementation of farm drains. Poor land management has led to gullying development, In urban areas, we've tried to get rid of water by putting in from the Victorian era storm sewer systems. And although this is idealized, what we're looking at is the types of changes that have happened to our catchment and to surface drainage. But this is the result. So again, you're looking at discharge, you're looking at time, and instead of a low peak and a broad flow period, we're looking at what we would call a flash hydrograph here, a flashy regime, where we have a very quick rise to a peak flood, which is much, much higher than previously, and a slower time of the floodwaters existing in that location. A second example, I've mentioned this before, is the distribution of wetlands in our catchments, both in our uplands. So these wetlands would be the extensive blanket bogs, for example, that we have up in our mountains, and then some of these valley bottom wetlands. And again, we have a similar hydrograph to that we showed previously. These have all been drained through the installation of drainage, some of it through the arterial drainage network, and the resultant hydrograph is similar to the one showed before. So the changes we have made on a catchment scale to our landscape has increased the flood hazard, and this is before we're looking at the impacts of climate change. If we want to look at how these changes in land use have affected the actual configuration of our channels and floodplains, let's look at the case study of an idealized deforestation, where we have removed our forests because of a change in land use from forestry to farming. So what you're basically having is pre-settlement. You had lots of riparian zone, alluvial forests growing adjacent to our rivers. This is the river channel here with water in it and some channel sediment. Once we began to clear the land, we removed all of the ecosystem services that trees provide, and that includes intercepting water, but also keeping the soil on the land. And so it now was free to move when it rained, and that sand was transported, and silt and clay was transported to the lowest point in the landscape, which is the bottom of river channels. And so what has happened is that the river channels began to become more dynamic to try to adjust to all of this increase in sediment, and their capacity relative to the flows that were now coming in much faster were reduced. So we were no longer able to handle the amount of sediment and water that was coming into our rivers. And the response of the river was to aggrade or to build up. And so because we have an increase in the runoff, so the rain running off our landscape, and we have a reduced channel capacity due to it filling up with sediment, what's happened is that peak flows have increased by 400%. And the suspended sediment, which affects our water quality and our aquatic habitats, have increased by 100%. If we look at our towns and villages and shopping centres and schoolyards, parking lots, let's call it urbanisation, what we've done is we've changed the shape of the surface from a naturally rough one with loads of topographies with trees and bushes and everything growing on them to a hydraulically smooth surface, and combine that with the dense drain network that I've alluded to already. So here is, and look at the scale of it, some of the underground human constructed rivers, pipes that transport water that we now have in our landscape. And this is what it has done. You're looking at the natural surface again at one of these hydrographs, discharge by time, low peak, broad kind of flow times after the installation of these storm sewers, because the purpose of them is to get the water away from the urban areas as quickly as possible, but it's going into our rivers. And so after the installation of storm sewers, you can see a huge increase in flood peaks, and then combined with that, the runoff just from the paved areas themselves, we have a very significant problem with both floods and the sediments and the sewage and all of the toxic chemicals that are basically washed off the streets, the oil, the petrol spills, all that kind of stuff, straight into our rivers. One of the more significant ways in which we in Ireland have changed the way our natural channels are is through a process of channelization, mainly through the arterial drainage network scheme. Here is an idealized cartoon of what our rivers may have looked like. Meandering channels with loads of riparian vegetation, which naturally reduced the force of floods coming down the valley because of the increased roughness. And the channels themselves would have had lots of what we call riffle and pool sequences. So this is just gravel kind of accumulations with deeper sections. You'll remember it from any time you've swam in a river. It's particularly around these bends. And this is what a typical idealized natural river looks like. This is what we have done in Ireland to our rivers. We have taken an approach that we want to get the water away from the land as quickly as possible. So we have straightened our rivers. We have removed a lot of our riparian vegetation, our natural vegetation, because we want to put our floodplains, that are alluvial soils that are drained very well and are nutrient rich, we want to transfer that into agricultural land. Now, for the aquatic kind of habitat, the lack of shaded trees will make the water relatively warmer, and it's just not good for our salmonoids and our general aquatic habitats. In terms of the channel floor itself, you end up with an assortment of gravels, which have lots of silt and finer sediment in it, and it's just not suitable for a lot of our aquatic species to thrive in. An additional effect of straightening our streams is the loss of these pools that are located with these riffle systems. And you can see that these were refugia for fish during natural droughts when the level in the river was much reduced. Now, with the straightening of our channels, what we can see is that the kind of reduction in roughness in the channel, we don't have bars in them, gravel bars and vegetation growing within the channel. We have much higher velocities, like just hooning down these river systems, basically moving the problem downstream. So it's not reducing the floods, it's getting the water away from a specific area and moving it down to cause exacerbated problems further downstream. So if you're ever talking to the older and sometimes very wiser members of your family and they say, sure, I don't remember floods like that and I don't remember this when I was a child, they're right. And it's not necessarily due to climate change. It's due to this history of what we have done and how we have physically modified our channels in recent history, in the last 100 years in Ireland, have led to a lot of the issues that we are experiencing now. So I've described some of the basics of our rivers in Ireland so we can better understand how to manage them if we understand how they work naturally. I've also very briefly described how we've changed that relationship, the human relationship with our landscape, and what impact that has had both on the landscape and on us. Now let's look to the future. Let's look to opportunities where we can kind of step back some of the more negative effects and enhance the positive ecosystem services that rivers can provide to us as a society, where we can live more in equilibrium with our natural systems and benefit from the positive feedbacks from those systems. There are a lot of terms out there that are used when talking in general about nature and how it can be utilized to help increase the ecosystem services that it provides to us. You might have heard natural water retention, nature-based solutions, natural flood management. So let's just forget all about the different terms and just talk about that, about how nature and using the natural landscape, natural vegetation, how that can be improved to help us mitigate against lots of the very serious issues that are coming down the line in terms of climate change. I am not going to advocate that nature-based solutions is the answer. It is part of the solution to a very big problem. So what we're trying to do is move Ireland from a very hard engineered approach to, in their response to some of these issues to also utilising nature-based approaches. And I think, to be honest, we need both. We need both in order to mitigate some of these significant hazards that we are facing.
What the process aims to do is to move towards restoration. You can't restore what's gone. It's gone. It's altered by human intervention. But we can move toward restoring the catchment processes that we have affected. And we can enhance their functionality in certain ways. For example, by planting native broadleaf species on hill slopes, retaining water in peatland drains. There are a number of measures that we can employ and deploy with the aim to reduce the hazards of floods in our catchments.
It's not just the story of water inundation, but also the movement of sediment through our landscape now in our modern environment. You will all probably have seen at one time or another, after a heavy rainfall, just after fields or shortly after fields are ploughed, the running of these muddy flows, removing nutrient-rich soil from the top centimetre of fields in rills and gullies down our roads and into our rivers, negatively impacting agricultural productivity and our river systems and water quality. And here is an idealized kind of sketch about, the before picture, what these fields might look like, and these are the erosional rills. Now, one of the nature-based approaches is to use natural soil and to build what's known as a bund, an earthen arcuate low wall that's about 50 to 100 centimeters tall, that will sit in the topographic low of your field and trap that runoff water and trap the sediment. And what that will do will be to prevent that water eventually reaching our rivers through our agriculture drains, through our road network. And this has been shown, as in this case here, to be very, very effective. And when we think about installing nature-based solutions, we have to appreciate that these are dynamic installations. These are not cement, and so they need to be maintained and they need to be watched as to how they respond to the environment and to go in afterwards to adjust them, to make them taller or longer, as actually happened in this case. This flood happened the day after installation, and the people who installed it found that there was leakage of water at the ends of this particular bund, and so they went back when it dried out a wee bit and extended that. So it's that kind of simple, intuitive approach to managing our landscape, I think, would work really well with the people who know our agricultural land, which is the farmers. They know the lay of the land, they know where the water goes, and if they were to receive payments for holding back this water and this sediment, I think we would be onto a winner for improving our flood hazard and improving our water quality issues. Another unit which can be soft engineered, but using natural products, soil, can be placed within those abandoned channels and floodplains, those natural topographic lows where water will naturally flow if the floodplain is reconnected to the channel. And these are known as offline flood storage ponds. And basically they will store the water, allow the sediment and nutrients that are carried during these flows to settle out and to be trapped in this area before being allowed through an outlet structure to flow further downstream. And so this is a very simple solution, simply engineered, that will allow the improvement of water that is running off agricultural land. An example of an in-channel natural structure are features that are known as leaky dams. So they're structures that are placed across relatively narrow channels. So this is suitable more for the upstream reaches where streams are small. And they are dams. So they're in place to trap water behind them, but they're leaky dams. So they're highly porous. So water moves through them. And you use the adjacent trees that either have already fallen down or you cut down some locally with permission. And you build these either formally using wire and nails or informally using the interlocking structure of the trees just toppled crisscross over each other across the river. And they serve during higher flows to basically not stop the flow, but slow it down. And you might get 20 seconds of a delay behind these kind of structures. And if you have multiple structures separated maybe every 50 or 100 meters, and you add up all of those 20-second delays, plus these get filled in with leaves and twigs, and they will trap sediment as well. So you have a reduction in the sediment eroded product from the adjacent land reaching downstream. Combined, these have been demonstrated to be very effective in both reducing flood hazard and in improving water quality in the UK. So finally, I want to talk very briefly about some progress that is being made. So one of the barriers to implementing nature-based solutions to our environmental issues has been governance structures. So the Water Framework Directive comes under the auspices of the Environment Protection Agency. The Floods Directive is dealt with by the OPW. And up until quite recently, they weren't really communicating with each other. They had enough to deal with, and there weren't any formalized communication structures between them. But that has changed. There was a national level committee set up by the OPW to deal with national water retention measures, of which the EPA was a predominant member, as well as all very important local agencies were represented. And indeed, both the EPA and the OPW have put together an EPA fund that we are now using to undertake research in natural water retention measures on agricultural land. So this is a project that I'm leading with colleagues in the UK and in University College Cork. It's called the Slow Waters Project. And the Slow Waters Project is basically intended to provide data on the efficacy of these measures, both for the attenuation of or the improvement of water quality, so feeding into the Water Framework Directive, and water quantity, the Floods Directive. And it's this approach of combining and opening up communication between the governance structures that really needs to be addressed for the future progression and deployment of funding mechanisms that will help us implement these nature-based solutions within our catchments at a scale that is required for it to be successful. So this is something that I envisage happening over the next decade, and within this 10-year period, I predict that we will have a much better story to tell about the water status and the outcome of the implementation of European directives for both water quality and floods. Thank you very much.